Okay, let's take a quick look at this practice mini quiz key together. So we're looking at the first problem, and you can solve it either way. You can not solve, but you can verify either this way or this way, depending on how your mind looks at it. If you notice right away that you've got cosine over sine, and you know that that is cotan or cotan squared, then your brain's going to think in a different way than if you looked at this and decided to change everything into sine and cosine. So just be really careful if you choose to do it this way. Changing it to sine and cosine is great. Remember, you have fractions within a fraction. So either choose your method of Kentucky Fried Chicken, right? Keep, flip, change, or go ahead and remember that the numerators get to stay where they're at. So cosine x gets to stay where it's at, so it would be cosine x. Sine x gets to stay where it's at, so it's sine x. And then the denominators of each of the fractions have to go. So sine x in the denominator and the numerator has to get kicked down here. And the cosine x has to get kicked up here. So either way you do it, whether you do it as a long division problem or you do the shortcut, you're going to get the same thing, right? Cosine squared x, sine squared x. And then you're going to change them to cotan squared x and add them together. So your choice, whichever way you want to do it. I want to make a note that your work has to go vertically. It has to keep moving down until you finally get to this part where this side matches this side. Don't stop too early. This side has to match this side. So be careful and make sure that you follow protocol. All right, so this next one was solving the equation, and this one looks a lot like the problem we worked on in our notes, and that's this. If you see something that looks like a quadratic, then you're going to pretend that it is. So instead of seeing it as 2 cosine squared x, you're going to write 2x squared. Instead of cosine x, you're just going to write an x, and then minus 1 is minus 1. So you're going to factor that. 2x squared, we're going to get that by taking 2x times x. And a negative 1, we know that one of these spots need to be filled with a negative 1, and the other one's a positive 1. I'm going to put my positive 1 here and my negative 1 here. And that's because to get this middle term, I know that my outer will be 2x, my inner will be minus x, so 2x minus x gives me an x. So I take this and I stop pretending and I write it. Instead of with an x, I write it with a cosine x. And then we go through, we set them both equal to 0. We notice that we are in an interval. And so that's why after we find our 3 angles, pi over 3, pi, and 5 pi over 3, we stop. We don't do the plus 2 pi n. And with this last one, we have to be really careful as we're working on this. I think most people did it the same way. Switching secant to 1 over cosine and just bringing down minus cosine x. Be really careful when we're looking at something that's a fraction and we're combining it with something that's not a fraction. Make that not a fraction. Put it over 1. And then that reminds us that we're going to go ahead and find common denominators. So to find our common denominator, right, we're going to multiply the denominator by cosine x and the numerator by cosine x, and that's how we get cosine squared x over cosine x. And then when we're combining fractions, just like if we were going to combine 3/4 minus 1/4, I know doing baby math looks funny in pre-calc, but we have to remind ourselves of some truth. When we're subtracting fractions or combining them by adding, we just rewrite the denominator, and then we do the math work in the numerator. 3 minus 1 would be 2. So that's why over here, we are just rewriting the denominator once, and then 1 minus cosine squared x is 1 minus cosine squared x. As soon as I see that 1 and the cosine squared x, it reminds me of the Pythagorean identity. Sine squared x plus cosine squared x equals 1. I want to manipulate this identity so that I end up with 1 minus cosine squared on one side. So I'll go ahead and subtract cosine squared x from both sides, and look what we have. We have that 1 minus cosine squared x is the same thing as sine squared x. So this kind of work that's over here, we do it to the side. We go ahead then and say, hey, instead of writing 1 minus cosine squared x, I'm going to substitute in its place sine squared x, and that's why this next step says sine squared x over cosine x. But the most unique part of this verification is what comes next. Somehow we have to take sine squared x over cosine x, and we have to make it look like sine x tan x. It's kind of like this. If we were to think about baby math, it would be like saying, well, actually, let me take one more step and then we'll do baby math. So my first step is rewriting the numerator. Instead of nice factored form not factored form, but nice simplified form sine squared x, I'm going to split it up and represent sine squared x as sine x times sine x. And the reason why I'm going to do that is it's kind of like saying, let me switch my colors. It's kind of like saying, hey, 4 times 4 over 2. I could rewrite 16 over 2 as 4 times 4 over 2, right? It's the same thing. And then I could rewrite 4 times 4 over 2 because 16 over 2 is 8, and 4 times 4 over 2 is also 8. I could rewrite it as 4 times 4 over 2. Do you guys agree with that? So that's still going to give me 4 times 2, which is 8. So that's what I'm going to do with this next step. Moving from this step to this step, I decided to rewrite sine x times sine x over cosine x as just plain old sine x times sine x over cosine x. So it's a little bit tricky. It's very clever, but now you've seen it, and you're going to be able to use it, especially when you see the mini quiz. You're going to use something very similar to this strategy of rewriting something that looks nice and simplified. You're going to break it down a little bit more until you see, this is awesome. Sine x matches up with sine x, and sine x over cosine x is tan x. Finally, both sides match. All right, so be sure when you're taking your mini quiz, be sure when you're working on any verification that you're moving vertically, that you do any of your side work on the side so it's not part of your verification, and that you do not stop until this side looks exactly like the other side. All right, thanks for joining me. Study from this and from your homework. Maybe read you some of your homework problems, read you these 3 problems on a separate sheet of paper. Practice really does make perfect, so make that time to practice. All right, I'll see you in class.